Fuel cells don't need to be recharged. They can be used constantly provided that the fuel keeps getting put in. The fuel that is normally used in fuel cells, hydrogen, can be a bit tricky to store because it is a very light gas and so it needs to be pressurized to make it possible to store a lot of hydrogen in a small space. However, what makes hydrogen fuel cells so exciting is that their only product is water. And when the hydrogen is made renewably, there are no emissions whatsoever, making them great for the environment. Fuel cells generate electricity from the reaction between a fuel, which is normally hydrogen, and oxygen. Earlier, we showed how water can be separated into hydrogen and oxygen. Well, it turns out that hydrogen and oxygen actually quite like being together, so we'll get back together whenever they have the opportunity. More scientifically speaking, hydrogen gas and oxygen gas will react rapidly to form water, provided that they are given some help to do so. This help can be provided by an external source of energy, such as a spark. And once they have started to react, they can do so very quickly and sometimes with explosive force. In a fuel cell, however, the hydrogen and oxygen molecules are kept separate from each other, so they cannot react explosively. They are separated by a special polymer membrane called an electrolyte, which does not allow oxygen or hydrogen molecules to pass through it. It does allow possibly charged hydrogen ions known as protons to pass through though. These protons are produced by passing the hydrogen molecules over a platinum metal catalyst, which splits them into the protons and electrons. This splitting process is called oxidation. The electrons flow through the anode electrode into an electric circuit to power, for example, the motor of a car, and eventually end up on the oxygen side of the fuel cell. The protons pass through the membrane to the oxygen side when they are able to react with the oxygen molecules and the electrons to produce water in a safe and controlled manner. Again, with the help of another platinum catalyst, this is the cathode electrode. This is the overall reaction that makes place then in a hydrogen fuel cell, so the word equation would be hydrogen plus oxygen goes to water. Chemically, we could express this as H2 plus O2 goes to the H2O, and remember that we need to balance this by putting a 2 in front of the H2 and a 2 in front of the H2O. So a fuel cell will use this process to produce an electrical energy, heat, energy, and water. It is a very efficient way of converting the potential energy available, especially when compared to normal combustion engine cars. One potential use for hydrogen fuel cells is in cars. The major advantage of this compared to normal cars is having no pollution emissions. The hydrogen gas is, however, more difficult to store and transport compared to liquid petrol. Although this can be an advantage, in an accident, the hydrogen will just escape into the air, unlike a conventional fuel, which can cause large vehicle fires. Currently, there are only a few hydrogen refueling stations across the country, and the development process for making zero-carbon renewable hydrogen is in its infancy. This means that developing the infrastructure and the process for producing hydrogen is currently expensive. This is a disadvantage compared to battery electric cars, which can be charged at home, and normal cars, which have fuel stations everywhere. Hydrogen cars can, however, be refueled more quickly than battery electric cars, in around 5 minutes compared to several hours to recharge a battery car using standard charges. Batteries hold very little energy compared to a hydrogen